Hello everybody. Today we're going to be taking a look at 2D kinematics, or 2D motion. In order to learn this topic, we need to actually review 1D motion. So remember in 1D motion, an object in motion can have an initial position, d0, a final position, df, an initial or final velocity, v0 or vf, and a constant acceleration. It's also worth noting that there's a displacement delta d given by the change in position, so the final position minus the initial position, and a change in velocity if there is acceleration. So an acceleration will mean a change in velocity, and a change in velocity will mean an acceleration. The equations that you need to remember are these four right here. These are the main ones. There's v equals v0 plus at, d equals d0 plus v0t plus 1/2 at squared. There's v squared equals v0 squared plus 2a d minus d0, and there's d equals d0 plus v0 plus v over 2 all multiplied by t. These are the main equations of 1D motion. Now, when we take a look at 2D motion, the one thing that your teachers don't actually want you to know is this trick right here. 2D motion is just 1D motion in two directions. The x direction and the y direction. So whenever we do any calculations, whenever we do any work with 2D motion, what we're really doing is we're doing this stuff up here in two different directions. We're going to be doing it in an x and a y direction. If you take a look at v, d, and all this information here, all of these are vectors. So the velocity is a vector, the position is a vector, the acceleration is a vector, and a vector can have components, an x component and a y component for you guys, okay? So the way I like to remember it is this little quote right here. The x stuff affects x stuff, the y stuff affects y stuff, but they have time for each other. So that is to say, when you're doing any sort of question using 2D motion, do all of the x stuff by itself. Do all of the y stuff by itself, but if you need to go between the two, you have to find the time, or you have to connect them with time. Because all of these vectors, or all of these quantities are vectors, you need to work with their components. And what that means is these equations up here, these four main equations, are actually going to change. When we do any work in the x direction, we said the x stuff affects the x direction. Well, this first equation right here, we can rewrite this as the velocity in the x direction is equal to the initial velocity in the x direction plus the acceleration in the x direction times time. This second equation here is going to be the position in the x direction is going to be equal to the initial position in the x direction plus the initial velocity in the x direction times time plus 1/2 ax times t squared. All of these quantities are the quantities that affect only the x direction, okay? These are the two main equations that you're going to be using, but we can do the same thing with the other ones down here. But similarly, if you're just dealing with the x components right there, that's what those equations look like. But you can also deal with just the y components. So the velocity in the y is going to equal the initial velocity in the y plus the acceleration in the y times t. And the y position is going to equal the initial y position plus the initial y velocity times time plus 1/2 acceleration in a y direction t squared. Okay, so just break them into components, the x direction and the y direction. Let's take a look at an example of how to use these things and how breaking things into components is going to help us solve those 2D kinematic problems. So let's take a look at this question right here. This question reads, a robot experiences a constant acceleration of 8.850 meters per second squared north. If it starts with a velocity of 1.065 meters per second east and travels for 18 seconds, what will its final velocity be? Let's take a look at the given information first. We're given an acceleration in the y direction of 8.850 meters per second. This is a positive number because we're going north. We're given an initial velocity in the x direction of 1.065 meters per second. It's positive because it's going east, and we're given a time of 18.0 seconds. For this problem, when we draw our reference frame, what we're going to be doing is we're going to be drawing the northward direction as being positive and the eastward direction as being positive. So everything will be relevant, referenced to this reference frame right here. The required information is the final velocity, VF. Notice that VF is a vector, so we're going to be needing a magnitude and a direction. Now, just before we get started with this, let's take a look at significant figures. We know the acceleration has 4 significant figs. so that'd be 4 sig figs. The velocity also has 4 sig figs, and the time only has 3 sig figs. So our final answer should have 3 sig figs as well. So I'm just going to write that down here. This will have 3 sig figs. In terms of our analysis, what are we going to do? Well, the first thing we're going to do is draw the diagram, the initial and final, and we're going to label all of the information that we're given or that we can infer for this problem. And then we're going to calculate the final velocity in the y, the final velocity in the x, use that to determine the magnitude, and we're going to find the angle theta with which the robot makes. So let's set this problem up and start with the initial situation. What does the initial situation look like? Well, we have some robot, and it has, let's say, wheels, okay? And it's moving in the x direction at 1.065 meters per second. It does not have a y velocity, and it does not have an x acceleration. So we can say that the acceleration in the x direction is equal to 0. So that means that this velocity should not change because the x acceleration will affect the x velocity. But we do know that this has a y acceleration. So it's going to be accelerating at 8.850 meters per second squared. Now we know from the problem that it's only moving eastward, so it has an initial y velocity of 0 meters per second. So we can use this in any of our calculations. After some time, 18 seconds, it's going to be moving with some y velocity. So if we take a look at the final situation over here, what is that going to look like? Okay, so this is going to be after 18.0 seconds. Well, this cart is now going to be moving, maybe pointed upwards like this. It's going to have some x velocity over here, and that x velocity is going to be exactly the same. The final x is going to be equal to 1.065 meters per second because the acceleration is 0. But it's going to have some unknown y velocity. It's going to be moving upwards at some speed. That's what we're going to have to calculate. What is it moving at after 18 seconds if it has this acceleration? So let's take a look at how we're actually going to solve this problem. Well, let's start off with the x components. Well, the x components we said were very, very easy. The final velocity in the x is going to be equal to the initial velocity in the x, which is 1.065 meters per second. We know this because the acceleration is 0. So I'm just going to write that in brackets here. Acceleration in the x is equal to 0 meters per second squared. Okay? The y components, however, they're going to be a little bit more challenging. Well, we have to use one of the kinematic equations that we know. Well, we know that the final y velocity is going to be equal to the initial y velocity plus the acceleration in the y direction times the time with which it's accelerating for. Well, if we take a look at our original problem, we said that it had a null y velocity or a 0 y velocity. So this part here, this variable here, this is going to go to 0. It started with 0 meters per second. So when we calculate our final y velocity, we only need to know the acceleration, which was 8.850 meters per second squared, and it was moving for 18.0 seconds. So if we run that through our calculator, we can find that 8.850 times 18 is equal to 159.3. The velocity in the y is 159.3 meters per second. Great. Now let's use the x components and the y components to calculate the magnitude of this velocity. How fast is it going in that diagonal direction? Well, if we want to find out the magnitude, we need to calculate the square of the x velocities plus the square of the, finally x, plus the square of the y velocities. So let's put those into our equation right now. We have the x velocity being 1.065 meters per second, and the y velocity was 159.3. Let's run that into the calculator right there. 1.065 squared plus 159.3 squared is going to be equal to 25377.62423. But remember, this is the square of the final velocity. If we want to find out what the final velocity is, we need to take the square root of both of those sides. Okay, so we'll take the square root of that answer, and we'll get the final velocity, or the magnitude of the final velocity, is 159.30356 meters per second, which is just a tiny bit faster than that y velocity. This means that it's going to be moving at an angle, but it's going to be at a very small angle. Okay, so let's find the direction. Well, if we take a look at the x and y components here, we know that it's going to be moving with some x velocity like this. That's going to be 1.065 meters per second. And we know that it's going to be moving with some y velocity, and that y velocity is going to be huge. It's going to be 159.30356 meters per second. And it's going to have some resulting velocity that goes off in a direction like this. What we're interested in is this angle right here. What is the angle between these two vectors? Okay, and we know that, this is just going to be 159.3, that's the y velocity. This resulting vector is going to be 159.30356 meters per second. Okay, so in order to find this, we're going to be using the SOHCAHTOA rule, or that the tangent of that angle theta is going to be equal to the y velocity divided by the final x velocity. So if we put that into the calculator, what's it going to look like? Well, if we want to find out theta, that's going to be the inverse tan of whatever this value is here. So VFY was 159.3 divided by 1.065. Therefore, theta is going to be equal to, let's take the arctan of 159.3 divided by 1.065, 89.6169 degrees. This angle is going to be very, very, very close to moving directly north. It's not going to be exactly north, but it's going to be very close because this y velocity is so much bigger than this x velocity. Okay, so how do we report our answer? Well, if you remember, we have to report it to 3 sig figs because the time was only reported to 3 significant figures. So the robot will have a final velocity of 159, get rid of all of that information there, meters per second, and an angle of 89.6 degrees north of east. And that's everything you know in order to solve this problem.